For our first example, we'll look at number 2. We were to write the polynomial in standard form and identify the zeros of the function and the x-intercepts in its graph. We're given the factored form of our polynomial, so if we're to write it in standard form, the first thing we have to do is to expand this set of factors. And if you notice that these last two are following the a minus b, a plus b pattern, we want to take advantage of that by simply squaring x, because a plus b times a minus b is a squared, minus b squared, and in our example, our b is the square root of 3 times I. If you square the square root of 3, you get 3, and I squared is negative 1, which means we get plus 3 by foiling those two. And then we've still got to bring in our other factor, x plus 2, so we'll FOIL this out to get our final standard form. And we distribute the x squared, and we get x to the third plus 3x plus 2x squared plus 6. And then the only thing we need to do to be in completely standard form is to rearrange those two middle terms to go in descending order of degree. And we get this as our standard form of f of x. And our zeros from the original factors, the only actual x-intercept is x equals negative 2, because that was the only real zero we had. And then our two complex factors gave us zeros, but they are not, in fact, x-intercepts. The x-intercepts are only the real zeros. And so our complex solutions are x equals negative 2, which is also an x-intercept, and x equals plus or minus the square root of 3i. And that's number 2. On number 6, kind of flipped it around on us, and they gave us the zeros this time, and we are told that we are to write a polynomial of minimum degree in standard form with real coefficients whose zeros include these two numbers. Well, here you see that we have the conjugate of each other, because you want to remember that on the ones where they only give you one complex number. So what this would be of minimum degree is a factor of multiplicity 1 for each of these zeros. So we do x, just like we would if that was 8 and 10. We're going to do x minus the 0 they gave us. But because these complex numbers have two terms involved in them, you want to make sure you put those in parentheses, because the minus that we include is distributive to both of those terms. So we're going to have x minus 1 plus 2i as our other factor. And then once we get that done, we have to FOIL this. Now pay close attention here, because this looks complicated, but it's a lot simpler than it appears to be. So if we FOIL this, we're going to do x times x and get x squared. And then we're going to do our outer product, which would be x times this 1 plus 2i over here. So that's, and they're both, well, no, this one's minus, so we're going to do minus 1 plus 2i, just like if that was, say, 10. We would bring it over here as our coefficient. We're going to bring this over as our coefficient for x. Then our inner pair is going to be minus 1 minus 2i x. And then when we do our last product, we get a negative times a negative gives us a plus. And then this is not going to be a simple number. We're going to write 1 minus 2i times 1 plus 2i. Let me try that again. 2i. And then that's our expansion. And then after this, we're going to just kind of collect like terms and distribute things that need to be distributed and whatnot to get us into standard form. X squared stays x squared. But then on this next one, notice that we have a minus and an x that are distributive to this 1 plus 2i. So a minus x times 1 would be minus x, minus x times 2i would be minus 2ix. Then we go over to the next one, have the same situation where we have a minus x distributing a 1 minus 2i. So that gives us minus x times 1 is minus x. Minus x times minus 2i is plus 2ix. And then we're going to get down here to the end and get these two complex numbers multiplied. Well, again, we're going to harness the power of the a minus b, a plus b pattern. And remember that when we FOIL that out, if you will, you get a squared, and I was about to do plus, minus b squared. Right, so we're going to square 1, so that's 1, and then minus 2i squared. 2 squared is 4, I squared is negative 1, so really that gives us a plus 4 at the end. So we're almost ready to get this written down as one simple little binomial, or not binomial, but polynomial. And we lose the minus 2ix and the plus 2ix, and then we have an x squared, and then we have a minus x and a minus x, so that's minus 2x, and then we have our plus 1 and plus 4, which gives us a plus 5. And that is our standard form of this polynomial. On number 10, again, they give us a set of zeros to use to write the standard form polynomial. But this one, they're kind of might be tricking you a little bit because they only give you one complex number. But remember, if a complex number is a 0, then we know we're going to have one that we kind of get one for free. So that's 1 plus I as well. So really, where they only gave us 3 factors, we really got 4 here. So our minimum degree is going to be a quartic or 4th degree function. So negative 1 is our first 0, means that x plus 1 is our first factor. 2 is our second 0, means that x minus 2 will be our second factor. And then we do just like we did on the previous problem, where we have x minus, and in parentheses, 1 minus I times our final factor, which is x minus, in parentheses, 1 plus I. And here we go again. I would suggest that you expand the first two first, so that you have x plus 1 times x minus 2 is a pretty quick thing to do, hopefully, at this point. So that's going to be x squared. Our outer product will be minus 2x. Our inner product will be plus 2x. I'm sorry, plus 1x, which leaves us with minus x. And then our last term there is minus 2. So that's what we get from foiling out that pair of binomials. So we're going to come down and do the same thing, a little uglier with the complex numbers involved, but no big deal. So we multiply x times x and we get x squared. We multiply x times minus 1 plus I, so that's minus 1 plus I x minus 1 minus I x for our inner product. And then our last times our last gives us plus, and then we're going to show that again, sort of a binomial looking product, 1 minus I times 1 plus I. Barely had enough room in the screen to get that one on that line. So now we're going to put it all together for that second factor. See if we can do a little better than that parenthesis. X squared minus x minus 2 times x squared, and again we have the minus x distributing the 1 plus I, so that's minus x minus ix. And then we're going to have minus x distributing 1 minus I, so that's minus x and plus ix. And then when we harness the power of a minus b times a plus b, we get 1 squared, which is 1, and then we have minus I squared, which is negative 1, so we actually get plus 1 out of that final term. And then we're going to get our second factor cleaned up so that we can multiply them together. and we get x squared minus x gives me minus 2x. And then this minus ix and plus ix take each other out for me. So we're left with plus 2. And then we distribute each term in the first polynomial across the second polynomial. X squared times x squared is x to the fourth. And x squared times minus 2x is minus 2x cubed. X squared times 2 is plus 2x squared. And then we're going to distribute the minus x. So that's minus x cubed. Notice I'm writing my cube term under the last cube term. Minus x times minus 2x is plus 2x squared. Minus x times 2 is minus 2x. Then I distribute my minus 2. Minus 2x squared, I write that under the last one. See if I can get that straight. Minus 2x squared minus x times minus 2x is plus 4x. Minus 2 times plus 2 is minus 4. And then, see if I can squeeze this last bit in. So we have an x to the fourth in our final answer. And then we have minus 3x cubed. And then we have these two cancel each other, and that leaves us plus 2x squared. And then we have minus 2x plus 4x is plus 2x, and then minus 4. And that, let me fix that ugly 4, is our final answer. And the end of this video.